Hey, in this video, I'm going to walk you through a little bit of a review for your midterm exam and kind of teach you, or hopefully teach you a little bit about how to study for mathematics. I always have a lot of questions about how to study for math. And that's kind of it's not a hard question. It's hard to explain because honestly, it just takes practice. I would say for me as a student, when I was working on my bachelor's degree, I did the wrong thing. And let me tell you what the wrong thing is. It is to memorize your review and memorize your homework and then expect to know how to do the test. So you've studied for hours, you've looked over all your homework, all your notes, all your review, you've memorized everything, and then you get to the test and you have no idea what you're doing. That's memorization. Memorization is not learning. Memorization can be helpful in a lot of ways, especially in situations where you need to know definitions or learn your lines or something like that. But in mathematics, it's more about understanding the concept and being able to apply it to different situations. So absolutely, you're going to come across situations in my class specifically where you've done the whole review, you understood it, you memorized it, but it wasn't like the test. You might feel that way, but it actually is like the test. It's preparing you for the test. So for example, if I put a lot of factoring on the review, I may not have specific factoring questions on the test, but you need to know how to factor to know how to do the problems on the test. And that's why I chose those questions. So it is very strategic. I know sometimes it may be frustrating that you studied really hard and you feel like it wasn't like the test, but it all has a point. So I have some pointers here for you on how to study for mathematics. How to focus more on the process rather than memorizing the steps. So first thing is to ask yourself, what is the question asking for? What is it looking for? And then what do I know about that? And then with what I know about that, those are the tools I need to solve the problem. So you have your toolbox full of all these tools and you're going to use those in this specific situation. And then you figure out, where do I start? You attack the problem, you check your answer, and then practice, practice, practice. So practicing, I would recommend, at first using the examples from the notes and like cover it up, have the example cover up the steps and work it on your own. And if you can't get it, then you're struggling with that and try again. And you keep trying that until you can arrive at the same answer as what's in the notes. And then once you get to the point where you're confident, that's where you start quizzing yourself with the review. Treat the review like a test. Try to put everything away, all your notes, all your examples, try to put everything away and do the review like it's a test. And do that review until you understand it, until you know how to do the problems on the review. And then also use the review as an indicator from the professor about what's important. So like I said earlier, I may have a lot of factoring questions on the review, but no specific factoring questions on the test, but you use factoring for the test. So I felt like factoring was important. So that's something that you might practice or something you might study. Or I might have a question on transformations of functions and I do a vertical shift. And then the test doesn't have a vertical shift, it has a compression or a stretch. Well, what I'm saying on the review is transformations of functions is important. Go back and study this. You may not have a vertical shift specifically, but you will have transformation of function. Not really in this case, but just an example. Anyway, okay, so that's some ways to study math, how to practice problems. On this particular test, we are going to have some cumulative material. So stuff from old units like analyzing functions, evaluating functions, linear functions, solving systems, and then our new stuff, which applies to quadratic functions. So in this first example, I have a picture of a graph, and we're wanting to analyze the function. So we're going to be talking about domain, range, and intervals of increasing, decreasing, and where the function is less than or equal to 0. So we have covered all of this stuff. It was in the very first unit, I think in the very first homework, maybe even. So you don't need to memorize this problem specifically. What this is an indicator that you need to remember and study what is domain, what is range, and how do I find these intervals? What do they refer to? So that's kind of that process up here that I'm talking about, how Okay, I've read the question. I know what it's asking for. Now, what do I know about those things? Or where are my gaps? So if there are gaps, then you have to go back in your notes and find those things and study them. So let's pretend like I know what domain and range is, but I can't quite remember what the intervals of increasing and decreasing were. So we know that domain, and if you want to test yourself on this, you can pause the video and do the whole problem and come back if you want. But I'm just going to walk through it. Domain refers to possible X values. Range refers to possible Y values. And I would do this. If you were doing your own review, instead of just working the problem, I would write out all that stuff. If you need the definition of the domain, write it out on your review. And that way it's fresh on your mind. And then intervals of increasing, decreasing, where the function's less than or equal to 0. So if you remember from intervals, what is an interval? How do we write intervals? What do I need to know about intervals? Remember, intervals were where we used parentheses or brackets. We talked a little bit about infinity and negative infinity. And then when we were referring to increasing, decreasing, and constant, I didn't put constant on here, but we did look at that. We are referring to X or Y. What did we use for the intervals? We use X. So again, in your review, you might write all that. Oh, wrong tool. You might write all that. And maybe even more. If that's unclear to you, you might even write when we use a bracket, when we use a parentheses, when infinity is appropriate, and all that stuff. So there's a lot more. I did not mean to put a ruler there. Get rid of that. Sorry about that. Okay, so domain is the set of possible X values. In this case, I have what's called a quadratic function. And I know that in a quadratic function, I can either look at it from the graph, or I would know from studying quadratics that all X values are fair game. I can use any X value. There's no X value that I need to exclude. Now, there might be graphs on the homework system where like it ends here with a closed circle and it ends here with an open circle, and that's a little different. But we're going to go ahead and assume that this goes on forever. It doesn't say that, but we're just going to assume that in this situation. And then if I were to look at possible X values, this is the X axis. For every single place on the X axis, I could find a point on the graph. So every single X value has a Y value. So this would be negative infinity to infinity. Remember, we always use parentheses on infinities. Yeah. Range refers to the Y values. Now the Y-axis is a little bit of a different story for quadratic functions. We can see here the Y-axis. My graph only goes as low as -3 on the Y-axis. And then remember, we assume that this keeps going up forever. So the lowest point is -3, and it continues on forever. And that -3 has a bracket on it because it's a solid curve. It's not dashed or dotted or have that open circle. So that's going to be a bracket. Increasing, remember, we took like a little marble or a car, or your finger or whatever. You start on the left side of the graph and take your marble, and it would be rolling downhill to here. And then that minimum point creates a critical value where it changes to going uphill here. And that place on the graph is at 0 for the X value. Remember, when we're talking about intervals of increasing, decreasing, and constant, we're referring to the X value where that occurs. So that goes from 0 to infinity because it is on this side. Starts at 0 and then all the way to infinity. I did put a parentheses on 0. That might be confusing because it is a solid line, but you'll see in the next part that I'm also going to use 0 on the decreasing. I don't know why it's lagging like that. Because my battery's low. So on decreasing, we know that it started over here and went all the way to 0 where it switches. So we start with negative infinity. You always start with the smaller side to 0. So that 0, since that 0 is included in both intervals, increasing and decreasing, that's why you use a parentheses there. And then the last one where f of x is less than or equal to 0, I wrote that weird for the sake of typing. We would normally see that like that. It's a little more appropriate, but it's okay. Less than or equal to 0. So where is the function below 0? Below or equal? I'm going to erase what I have up here because I've made a mess. So here's 0. Whoops. Yeah, it worked out. There's 0 on the y-axis. Where is the function below 0? Here. That'd be like the black line is like sea level, and then everything below that is like, I don't know, the bottom of the boat. And I don't know. That's a bad example, but it's below the water. So that part is below 0. That occurs between -2 and looks like 1.5 maybe. Well, no, a little bit past 1.5. I'm gonna guess 1.75, maybe 1.7. So less than or equal to 0. I did put a bracket because it is equal to 0 at those points. And that's all you got to do. So if that was fuzzy to you, you might go back in your notes and practice some of those problems, or back in your homework and look at some of those problems to cover that stuff. Next problem. And again, it might not be these exact problems on the test. I'm just kind of going back over some stuff that you could possibly see that might prove to be helpful. All right, evaluating functions. There's lots of different ways we can evaluate functions. We can plug it into a formula, not a formula, a function. We can look at a table of values, or we can look at a graph. So if I were just to give you this as your review, and that's it, no practice problems like I'm doing right now, and I told you you need to study evaluating functions, then don't limit that only to one type of problem. You need to go back and study evaluating functions in its entirety, and that includes graph function tables. So that's the questions I added to this review. So when I was in college, in my more upper level math classes, the teachers would give a review like this, and they would hand you that piece of paper and they'd say, good luck. And you're like, what do I study? That's a lot. Like, that's a lot of information, And so I would go through, if I were given a review like this, I would go through and I would make a review just like that, like I just did. I added a question where I could practice analyzing functions. And I added a question where I could practice evaluating functions, and so on. And I was super nerdy, and I would make my own reviews, and I would study really hard. So I don't know. It's fun for me. It's still fun for me. That's why I made a job out of it. Anyway, function notation. Okay, function notation is when you are given the function in function notation. So remember, function notation is just kind of a nice name for y, f of x. So it gives us f of x equals x squared minus 2x plus 3. Find f of -1. Remember, that doesn't mean f times -1. It means you evaluate this function at -1. So you just plug it in. Remember, put it in parentheses. And then you can either just type that in or evaluate it by hand. And when you simplify, you should get +6. So if I were to look at this function at the x value of -1, the y value would be 6. And that's a point on the graph. And then if I were given a table and I said, find f of -1, you locate -1 and its y value. So again, f of -1 is 6, which yields a point, -1/6. And then in graph form, f of -1, kind of big. Here's -1. If I were to track it up to the function. I got a little here. I'll draw it so you can see it. That is at 6. So again, -1, 6. The answer would just be 6, but I'm writing it as a point. So f of -1 is 6. That is your answer. So you can see here that I did, coincidentally, not really, 3 different representations of the same function. So I had the same exact function in function notation, that's just the equation. And then I wrote down a couple of the values from the table, and then I included the graph. And you can see that in each representation, when we plug in -1, we get 6 because it's the same function. Okay, next thing, linear functions. To review, we are going to focus on slope, y-intercept, and x-intercept. We did also talk about parallel and perpendicular, so you might go back and look at stuff like that. But the biggest stuff we covered was like writing equations of lines, converting equations of lines, graphing them, finding the x and the y-intercept. So that's all that stuff would be fair game. I just kind of put down here what I felt like was the most important. But if I were a student studying and I didn't know what was on the test, I would go back and look at all of that and try some problems. Okay, so what do we know about slope? We know we use m, and we know that we have a formula to find it if we have 2 points. If we don't have 2 points, we can also use slope-intercept form, where m is the slope. So that's what I know about slope. And then what do I know about y-intercepts? A y-intercept happens when x is 0. And then an x-intercept, oh, sorry, it's also where it crosses the y-axis. And then an x-intercept, it's when y is 0. And it's where it crosses the x-axis. So in my review, write down all the stuff I know. Now I look at the problem. I am given an equation in standard form. It's where x and y are on the same side, and it needs me to find the slope. Since I'm not given 2 specific points, I can attack this a different way. I could find 2 points and then find slope, but I think it's a little bit faster to convert this to slope-intercept form. And to do that, we isolate y. So we're going to subtract 14x and divide by -2. And that gives -7 plus 7x. I'm going to rewrite that because I like the x first. Nope, did that wrong. Could be careful when you rewrite it. I like the x first. It really doesn't matter, but I just like it in that form because that's slope-intercept form. And in slope-intercept form, you can see the slope. So our slope is 7. And then to find the y-intercept, you can either use your slope-intercept form or you can use the standard form. It doesn't matter. I'm going to stick with standard form for this problem. Actually, from slope-intercept form, you can just see the y-intercept here. So that's not very much work. Since I already did all the work up here, slope-intercept, I can see the intercept is -7. But let's pretend like I didn't see that. I can use my original equation, plug in 0 for x, and solve for y, and we get -7. So 0, -7. And then for the x-intercept, we do the same thing, but we plug in 0. Did I say y in the other one? We plugged in 0 for x. I'm sorry. We plugged in 0 for x here. I don't know what I said. Down here, we're plugging in 0 for y. It's the opposite variable. Whatever you're trying to find, you plug in 0 to the opposite variable. Sorry about that if I messed it up. 14x equals 14, so x is 1. And then to graph it, there's lots of ways you can try to graph this. You can just plot your 2 points that you found, or you can do slope-intercept form. So it doesn't matter. You're going to get the same line. So let's sketch a graph. For slope-intercept form, we have a y-intercept at -7 with a slope of 7. So we go up 7/1 and then draw our line. Mine's a little off. There we go. Or if you had chosen to do the 2 points, we have a point at -7, no, 0, -7, and 1, 0. And you can see that's the same. So same thing. And then for studying purposes, you could look at parallel, perpendicular. What else? I think that's all. Okay, moving on. Systems of 3 equations. Now, I think at the top I just said systems of equations, so you might want to review some of those word problems from the 2 equations. But for this one, I just focused on 3 equations because we could look at doing it by hand and by calculator. On the test, I don't specify what to use, so I would recommend using the calculator or doing it by hand and using the calculator to check yourself. That's probably what I would do. I'm super nerdy. All right, so by hand, we've got a system of 3 equations, and I'm noticing off the bat that this third equation doesn't have a z value. So I'm going to use that to my advantage. I'm going to see if in my first 2 equations, if I can eliminate z easily. And if I can, then I've kind of saved myself a step. And you'll notice that the z's are inverses. So it is actually nice. Let me run out of room here. -x plus y minus z equals 2. The z's are inverses, so we get 1x minus 3y equals -7. And that's my new equation. That's 1, 2, 3. So I'm going to use 3 to eliminate further, to break it down further. And you can eliminate x or y. Doesn't matter. You can pick. I'm going to pick x because I think it's going to be easy to subtract this whole line. X minus x is nothing. This changes to positive. This changes to positive. So y is 3. And then since I have y, I can back substitute, find x, and then back substitute, find z. Okay, I got 2 for x, 3 for y, and -1 for z. And now I'm going to use the calculator to check my work because I sometimes make mistakes on these. I get ahead of myself. All right, so if you were to be studying on your own, then a good tactic here is to actually write down the steps to solve it using a calculator. And then, because if you solve it using a calculator and you just write the answer, what does that help when you're studying? It helps more to know how you got there. And that's the whole point of math, is knowing how you got there. What tools did you use? So instead of that, because I know the answer, or at least I think I do, I'm going to write down the steps. So I'm going to pull up my calculator, clear it, and I'm going to write down the steps so that when I'm going back quickly before class and looking at my review, because I'm really nervous, I see those steps one more time and I'm like, oh, okay, I remember how to do that. All right, so step 1, I need to input my matrix. So I'm going to go to second x to the -1. And then I'm going to go to edit. I'm going to grab any of these. I'm going to grab A. And it is a 3 by 4 because there's 3 rows and 4 columns, X, Y, Z, and the constant. And then I'm going to input my values. write my step. Input coefficients. Make sure when you input your values that you check them. We have two. I'm glad I checked. 2, -4, 1, -9, -1, 1, -1, 2, and then 1, -2, no z value, -4. So make sure you check it. That really was an accident. And then I'm going to go to second mode to quit. Whoops. Second mode, there we go, to quit. And then I'm going to go back to matrix, second, x to the -1. And then I'm going to go over to math. And I want B, reduced row echelon form. And then I'm going to grab my matrix. So go back to matrix. And it was A that I was looking for. Enter. And that last column, 2, 3, -1, that's X, Y, and Z. So for your calculator, that is kind of a lot of steps, but long story short, it's a lot of like second X to the -1, like going back into the matrix, edit your matrix, get out of there. Go into the matrix, get reduced row echelon form, get out of there. Go into the matrix and grab the matrix that you were working on. So it's not really hard. It just takes some practice. So I would recommend definitely going back into your notes or your homework problems and just practice pressing those buttons, just doing it over and over again. It's muscle memory. Uh-oh. I got to figure out how to fix that. The light turns off when it doesn't see me. Okay. And then the last two things on here are about quadratics, which is the most recent unit that we've covered. So I'm just going to cover a few things, but I would recommend going back and looking at maybe just glancing over all the stuff that we looked at, maybe doing some practice problems. Again, the most important stuff here is going to be solving quadratics and then writing the equation of a quadratic. So for this particular problem, I'm going to solve the same problem 3 different ways, but just know that on the test, you may be given several different types of problems, they may look different ways. I just picked one that I thought would be a good representation of some of the stuff that you need to remember, basically. So for factoring, in order to factor this, we need to simplify, get everything on the same side, and factor. So I've got x squared plus 8x equals, if I were to simplify, I get 16 plus 8x. Get everything to the same side. I'm going to subtract 8x. I'm going to subtract 16. Oh, that turned out nice. So this is actually a difference of 2 squares. So if I were looking for factors of -16 that add to nothing, because it zeroed out right here, that's going to be a +4 and a -4. Split that up, solve each one, and we have our 2 solutions at -4 and 4. You could have solved using the square root property right here. Forgot equals 0 right here. Or you add 16, square root both sides, and you get ±4. So that's another way. I didn't put that on there, but that's another way. And then completing the square does, I didn't put the square root property on there because completing the square uses the square root property. But for completing the square, we did the shortcut on this, I think. I was going to show you the long way. I forgot. We did the shortcut on this. And that shortcut was using vertex form. So vertex form is y equals a times x minus h squared plus k. Vertex form. Something to study. And then to do that, you have to know the a value and the vertex. So we're still going to kind of do some of the same stuff here. We know the function simplified is x squared minus 16. The a value is the number with x squared. And then the vertex is x equals negative b over 2a. There is no b value. The a value is 1. That's 0. And then the y value, you plug in 0 and evaluate. And we have our vertex at negative 16. I've run out of room here. We're going to keep going. We're going to pretend like this black line doesn't exist for a second. Y'all bear with me here. Just pretend. Erase. Done. Okay. And then we plug in our pieces. Y equals a times x minus h squared plus k. The a value was 1. We leave x. Oh, I need to rename this. I need to call this h and k. They're the same thing, just for the sake of this problem. I'm going to rename them h and k. X, k. Simplify. And then if we're solving for x, you add 16, square root both sides, simplify. So this one was kind of weird because the middle term was 0, so it kind of made it a little easy, but or the h term, sorry. The h value was 0, so it made it kind of easy there. If you did have an h value, actually, I would just go back for the sake of the length of this video. I would just go back and find one in the homework or the notes where there was an h value and practice solving like that. Like, what would you do in that scenario? Or maybe, I don't know if there's, I'd probably do that. Sorry, I keep backtracking. I'd probably do that. But the process is the same. We're still going to find a, we're still going to find h and k. We're going to plug those in, set them equal to 0, and solve. So set equal to 0, solve for x. That's the last step. That's all. Let's complete the square. Okay, last one, quadratic formula. Again, we're going to simplify the function. Same function. We're going to identify a, b, and c, and then plug it into the formula. B squared minus 4ac all over 2a, and simplify. Okay, again, since this one, the b value was 0, it ended up being really simple because when you plug in 0, you get negative 0, which is just 0, plus or minus 0 squared, which is just 0, minus 4 times 1 times negative 16, which is positive 64, all over 2. Square root of 64 is 8, divided by 2, and we get that plus or minus 4. So you can see in every scenario, we get plus or minus 4, whether we do quadratic formula, complete the square, or factoring. Or actually, we did another one, square root property, again, plus or minus 4. Same function, get the same answer. All right, last one we're going to review is writing the equation of a quadratic. And so I picked a sample problem here where we're given the vertex and a point. So if you're given the vertex and a point, you want to use vertex form. And we've already kind of looked at that with completing the square. And then plug in what you know. We know that HK is 1, 2, and we know that XY is negative 2, 11. So we plug it in. Okay, so we do know the y value, the x value, the h value, and the k value from the information given, which means that all we have to find is a as far as missing information. So we're going to simplify equals 3 squared is 9, a plus 2, subtract the 2, divide by 9. So we have the a value, but that's not the equation of my function. The equation of my function is y equals the a value times x minus the h value plus the k value. And you leave x and y as unknown variables, because if we were to plug this into like a calculator or try to graph it, we need those two variables so that we can plug in different values. If we just plug in the x and y values that were given back here, then we just end up with a constant. We end up with like a true statement, and that doesn't really help us. To write an equation, we need to have the x and the y value in there so that we can plug in any x or y value and find lots of information about it. So that's how you write the equation of the line. If you needed to solve for x, you would just set it equal to 0 and solve using your square root property. So that's all I have for the review. I have at the bottom to make sure that you take a look at simplifying radicals with a negative. So for example, square root negative 64, you'll need to know how to complete that, or not complete that, simplify that, or square root negative 128, stuff like that, in case it's on the quadratic formula stuff. And then lots of factoring and the square root property. So I hope this helps. If you have any questions, let me know. I'll be happy to help, and I'll see you in the next one. Good luck.